and subtract with unlike denominators. That would be on page 112. Now for these, it's a good habit to get into rewriting the problems as you see them and rewriting them vertically with one fraction on top of the other, because it helps keep everything neat, orderly. When we have to convert, it's going to make things a little bit clearer to see what it is that's going on. Pardon me? Add and subtract with unlike denominators. Christmas. Okay, so I need to convert 5 and 15 to have the same denominator. Now the trick of this is you want to focus on kind of like when we compared fractions before, and we can only really compare them when they have the same denominator. When I add and subtract them, they have to have the same denominator as well. So I'm going to start by looking at the larger of the two denominators. So between a 5 and a 15, it's easy to see that 15 is larger than 5. Now the first question I'm going to ask myself is 15 the way it stands as my largest denominator also a multiple of 5? If I were to count by 5, would I eventually get to 15? Yes. So I'm going to stay with that one. I'm going to convert them both to new fractions. Well, one of them will be new, with 15 as the denominator. So here's the trick. If I transformed this first fraction, which is 3/5, to another fraction with 15 as the denominator, how did I go from 5 to 15? Times 3. So I would also do the same thing to the top in this particular fraction, and it would be a 9. Here, did the 15 change? So neither does the 4. Any questions on what we just did?
That actually makes sense.
Jan? When I add what? We didn't add anything yet. We're just setting it up. Tyler? Like the multiples, like the numbers that, okay, so if we have 5, we'll count by 5. It's 5, 10, 15. Oh, 15, there it is. Okay. So now we'll get to the adding. 9 plus 4 is, are we adding the denominators 15 and 15? Therefore, our final answer is 13/15, because 13/15 cannot be simplified. Okay. Any questions there? Okay, we'll do some more, but for openers, we're on the right track, yes? Let's try another one. 1/8 plus a 7/16. Again, it's a good idea to write it out that way. I think it makes it easier to see, at least until you know you got the hang of it. Your main goal on top of comprehending everything is to avoid mistakes which you should not be making. I haven't seen it. I don't know if she's bringing it with her to other classes. Maybe ask. Yeah. All right, so 8 and 16, which one is larger?
16.
Does 16 as it stands work for 8?
Yes.
All right, so that's going to stay the same. To get from 8, which was my previous denominator, to 16 is times, so multiply the top times 2. 2. Got common denominators, we're good to go. 2 plus 7. Do 9 and 16 have any factors in common in which I can break them down? Therefore, we're good. Fred. Don't overthink this. Okay? Don't overthink it. Now, the other thing is this. If, let's say, you don't have to write this down if you don't want to. Let's say I'm looking at the 8 and the 16. I'm trying to come up with a common denominator. And I think that it's 32. Can we still get the right answer?
Yes.
Let's find out. So now, 8 times what is 32? 4 times 1? How about 16 times what is 32? 2. 2 times 7? 14. Now, 4 32nds plus 14 is 18 over 32. Is that the same thing that we had before? Yes, it is, as long as we simplify it. So, as long as they have a common multiple and you do everything else correctly, you should be able to get the right answer. However, if you don't pick the smallest or least common denominator that they have, which in this case was 16, if you pick something else, you will always have to simplify at the end. Always, always, always. Always. Now, using the smallest or least common denominator here won't guarantee that you won't have to simplify. There are some cases in which you'll still have to simplify. But at least you give yourself a chance of not having to worry about it. Okay? I'll give you one to try. One third plus 1/2. All right, Sydney. Are 3 and 2 the same? No, they have to be the same. If I'm going to add them, they have to be the same. So I'm going to have to rework. Remember that whole long time ago when we made equivalent fractions? We said we can make them the same thing if we use multiplication, right? So I'm going to look at the 3, and I'm going to count by 3s and see what's the next one that's shared by 2. So 3, like if I count it by 2s, what I get? It's 6, right? 3, 6. So I have to convert them both to sixths. From here, now I say, okay, 3 times what is 6? So if I multiply the bottom times 2, then I also multiply the top times 2 and get 2. Here, are we still multiplying by 2? No, here we're multiplying by 3, because 2 times 3 is 6. 1 times 3 is 3. 2 plus 3, 5, 6. Okay? We have to convert. Okay, let's try that one. Okay? Some of you simplified this here, and you say, wait, 21 and 15 both have 3, so I'm going to divide them both by 3 and get 7 over 5. Is that okay? Yes, only if you do what?
Fix it again.
Still got to fix it. 5 into 7, once, 2 left. We still get 1 and 2/5, but we just have to convert.
So you still did the same amount of work.
We still had to break it down, whether we did it first or after. Okay. Try this one. 5/6 and 1/4. Yeah, let's subtract those. Good idea. I'm going to look at the 6 and say, okay, when I count by 6s, 6 doesn't work for 4, but my next multiple of 6 is 12. 12 works for 4. I'm going to use 12. 6 then times 2. 5 times 2 is 10. 4 times 3. 1 times 3 is 3. This isn't going to work. Georgia, switch back with CJ. 10 minus 3. 10 minus 3. 7 over. You might not be able to see as well, but you can hear better. And if you can hear it, that's better than seeing it. Any questions? Yes? So when you have these two denominators, right, 6 and 4, okay, we're looking for multiples. So count by 6s. Count by 4s. Okay, so what's the first one that you see that they have in common? There it is. Notice, well, no, actually, oh, for 6 and 4, yeah, so that's why we got 12. That's how we get that. And that's why I say if you start with the bigger one, you count by 6s, and you start with 6. Is 6 a multiple of 4? Do we see 6 here? But the next one up from 6 is 12. 12 also works for 4. Okay? So then, okay, so here's what I had first, right? I had a 6, but I changed it to 12. So what did I use multiplication-wise to get from 6 to 12? So if I multiply the bottom of this fraction, I multiply the bottom times 2, then I have to multiply the top times 2. And over here, 4 times what gives us 12? 3, so I'm going to multiply the top. 1 times 3 equals 3. That's how we get it. Josiah? What if there's an earthquake and the classroom splits in 2? Like, what side are you going to want to be on? You know why that's not possible? Because you can take any two denominators and multiply them to each other, and there you have them. So any of the numbers that you'll have for fractions, look at the last ones. 6 and 4. If you were to multiply 6 times 4, multiply this one times this one, what do you get? Is 24 a common denominator of 6 and 4? Is it the smallest one? No, but it's a common one. All right, look at side 7-5. So there's only one, there's 7-5 and there's 7-6. So look at 7-5. We're just going to do numbers 7 through 12. 6 problems. Okay.